All right, everybody. So if you do not have a notebook out yet, you should get one. We've got a couple of things to talk about today, and then we'll be done. How was lunch today? That was fun. Okay, so this section is going to be titled Rational Numbers. (3-1) Rational numbers. Luckily, we already know what those are. So today, we're basically going to be talking about ordering them. So before lunch, I had you guys do that activity. I gave you all a random number and I asked you to order yourselves from least to greatest. We talked about some strategies, lining up the decimal. If you need to add zeros to the end of a decimal, you can do that without changing its value. So that's really our easiest way. However, not all rational numbers are decimals. Some of them are fractions. And well, before we get into that, let's talk about, I said that we would go over the negatives with decimals. So just to recap, when you are on the number line, the further you go to the left, the smaller your number gets. The further you go to the right, the bigger your number gets. That's why when we go to compare things that are both negative, it's kind of the reverse of what it normally is. So if I want you to compare the numbers -6 and -5, 6 is normally bigger than 5, but when we're in negative land, everything is different. Because wouldn't -5, right? If you just make the line -1, -2, -3, -4, -5, and then -6. So you can see -6 is actually going to be smaller than -5. Let me get this in focus a little bit better for you. There we go. So if I'm comparing these two, that's the way it goes. Now, let's make things a little bit more interesting. Let's talk about some decimals. What if I wanted to compare the numbers -2.6 and -2.9? Out of these two, which one is actually the bigger one? Connor, go ahead. Yes. If they're both negative, it's basically the opposite of what it would normally be. Right? So if they were positives, 2.9 would certainly be bigger. So since they're both negative, I got to go the other way. When you are comparing a positive and a negative, so if I had something like 0.00003 and I wanted to compare that to negative, I don't know, 7. You don't even have to think about these really, because automatically any positive number, no matter how small it is, a positive number is automatically bigger than any negative number. So you don't even need to consider what the numbers look like. If they don't have the same sign, it's basically telling you the answer. The positive one is always bigger. Yes. Let's add that even. Positive number is always bigger. Okay, but now let's move our attention away from decimals and let's talk about fractions. Some fractions are really easy to order, some not so much. So let's start off with an easy one. Okay, so let me give you a couple of, we can do letters again. I'll give you 5 different fractions and I want you to order them from least to greatest. And we're gonna start, this will be easy round. So how about we do 5/9, 7/9, -1/9, 8/9, and -5/9. If I ask you to order these from least to greatest, the reason why this is an easy round is because all of the denominators are the same. They're all ninths. So I really can just look at the numerators and kind of just order those. So keeping that in mind, which fraction, let me call on you at random, which fraction has to be the smallest in the whole bunch?
-5.
I call yours, but thank you, you're right. It is -5, right? So that one's gotta be, if I'm going least to greatest, E is gonna come first. The next one after that would be, oh, well, I had called Noah. So Noah, what's the next smallest? Don't tell him. If -5/9 is my smallest, the next smallest is probably gonna be, say it again. I think you were right. I just wasn't sure. Yeah, -1/9. That's my next smallest number. If all the denominators are the same, we're really just ordering the numerator. So -5 is the smallest. -1 is going to come next, so that'll be C. Who is next after that? Suk.
Which one?
We've already done E and C. Who's got to come next? We're going least to greatest.
Wouldn't it be A?
Yes. +5/9. Now here. Francisco, can you tell me the next one? We did E, C. Who's the next bigger after 5/9?
E.
Yes, 7/9. So then obviously the biggest in the whole group is going to be D. 8/9. All right, great. So when I have common denominators, it's not so bad. What happens when you don't have common denominators? So I'll just add easy when all denominators match.
Don't you have to turn into decimals and not?
So you have a couple of options. One option is to do exactly what Christian just said. You can turn them all into decimals. So if you have access to a calculator, what if they don't? So let's try the same thing. I want to go again, least to greatest. And I'm going to show you 2 different ways. Well, maybe I guess 3 different ways to kind of work your way through this. So I'm going to do one that's not terribly bad. So let's try, you know what, I'm going to start this off easy. So I'm only going to have positives right now, and then we'll work our way up to some negatives. What if I had something like 1/2, 1/5, 7/8, maybe like a 3/4. Say I wanted to order these 4, A, B, C, D. So one thing I could do is literally change all of them to decimals. So I could grab a calculator. I can do 1 divided by 2 is 0.5. 1 divided by 5 is 0.2. You could go decimals and then order them like we have been with the decimals. That's one option. However, there might be a faster way. If you can look at these, there's only 4 of them. We might be able to just reason our way through this. First of all, if any of them were negative, they'd automatically be on the small end, right? In our case, all of them are positive. So let's think about this. If you were, think about these as pizzas. If you ate half a pizza, a fifth of a pizza, 7/8 of a pizza, 3/4 of a pizza, which one are you eating the least? Which one of these 4 would be the least amount of pizza? Imagine we had 4 pizzas.
1/5.
Yes, right? So imagine all 4 of these were the same size pizza. This one would just cut into 2 pieces, 5 pieces, 8 pieces, 4 pieces. So if you imagine what they look like, 1/5.
Has to be the biggest, right?
Exactly. In this case, so sometimes you can reason your way. 1/5 is definitely less than half. It's a very small amount. So I'd say B is the smallest. And now I might just ask myself, okay, so Christian already said 7/8 is, that one's really close to being a whole pizza, right? 7/8 is almost the whole thing. So let's talk about 1/2 and 3/4.
And then 3/4 is next, and then 1/2 is. 3/4 is bigger, right?
3/4 is bigger than what? Yes, 3/4 is bigger than a half. So sometimes you can get away with just doing it in your head and saying, okay, well, this one, I always start with who's the absolute smallest, or I might even say, okay, who's less than a half and who's bigger than a half? Even if a half isn't one of my options, because it's usually easy to tell, all right, these ones are on the small end, these are on the bigger, and I might be able to work it out that way. There is another option, which I wouldn't do for one like this because this was easy enough to reason in our heads, but sometimes they're not. Sometimes they're really kind of too close to each other. I'm not sure what to do. So let's try another one. So again, I always want least to greatest. So let me give you ones that are trickier. Like, what if I had, oh, I don't know, how about 5, 6. 7/8, 2/3, maybe, let me throw one more in there. How about, 7/12? Let's go with that. So one other option, because this is a little bit too hard to do in my head. I don't know. I feel like they're all bigger than a half, so there's not immediately one of them that's jumping out. So I could grab a calculator and turn them into decimals. But there's another thing that I can do. Remember how easy it was when all the denominators were the same? I can make all of these denominators be the same. And then it's really not that bad to get my answer. So if you look at all the denominators, 6, 8, 3, and 12, can you tell me a number that all of those can divide into? 6, 8, 3, and 12. I want a number that they divide into evenly. Here's my method for doing that. I take the biggest one and first I ask, okay, can all of these numbers divide into 12? 6 goes into 12, 3 goes into 12, but 8 doesn't. So, okay, too bad, so sad. Now, all you have to do is take 12 and think about its multiples. So, if I take 12 and I multiply it by 1, I get 12. If I multiply it by 2, I get 24. Can all of my numbers divide into 24? Yes. So what I can do is make everybody have a denominator of 24. So one way to do that, I just come in here. I should have left myself a little bit of room in between them, but that's okay. So this one, I would just have to multiply by 4/4. Right? And wouldn't that give me a 24 on the bottom? You see that? If I wanted to turn this one into a 24, I multiply by 3/3. This one, multiply by 8/8. And this one, 2/2. So it might take me a minute to set it up, but once I have it, so let me rewrite my new fractions. I'd have 20 24ths, 21 24ths, 16 24ths, and 14 24ths. And now it's so easy to order them because they all have the same denominator. So now I can very quickly see my smallest one has gotta be, yes, D, 14 24ths. So D comes first, followed by C, and then A, and lastly B. Yep. So that's an option as well. Okay, so if you have a calculator and you like going to decimals, you can do that. If you don't, you can always get common denominators and work through it that way.
What?
What?
You say my name?
No?
Oh, okay, so-
I said you can always get common denominators and work through it that way. Any questions? No, we're all right. Okay, so let me go ahead and give you your homework. I don't think I opened it on Jupyter yet, so give me just a second and I'll do that. Post the notes and we'll be on our way.
The first one being
Is what, bigger?
Yeah.
Yes, any constant is bigger than a negative automatically. You don't even have to look at the numbers.